right, thank you, Aaron. Now I'm going to turn it over to Dr. Peter Westley, our keynote speaker. Dr. Westley is Wakefield Chair of Fisheries and Ocean Sciences at the University of Alaska in Fairbanks. Is a lifelong Alaskan, and Peter spent over a decade outside Alaska at the University of Washington, where he got his BS and MS and postdoc, and Memorial University of Newfoundland. At UAF, Peter is the PI of the Salmonoid Evolutionary Ecology and Conservation Lab, whereas he and his students work at the intersection of ecology and evolution to help provide the best available science to help sustain the 10,000 plus year relationship between salmon and people. He currently lives in Homer on sabbatical with his wife Donna and son Ken. Peter.
Academic without slides. I don't know what I would say.
This one? Oh, this one. Yep.
Well, I'd like to echo Aaron and Tom, welcoming you to my hometown, Dakayakook. I grew up calling this place Anchorage. And you came at the best time of year. September is the most exciting time of year because winter's coming. There's a flurry of activity. Everything is trying to pack on energy for the long winter that's coming. So I hope you can get out, enjoy the sights. The trout are fat and happy. So enjoy. But it's also in that context of winter is coming that my thoughts are with fellow Alaskans and fellow humans on the North Slope, the Bering Strait, that have just experienced one of the largest storms on record. And my thoughts are echoing Dr. Catherine Hayhoe, who talks about climate change, saying that it's real, it's us, and it's increasingly becoming dangerous. And we've seen this, that this storm, absolutely driven by anomalously warm sea surface temperatures, puts at risk not only infrastructure, but people's subsistence foods that have been put up for the coming winter with a lack of power, freezers being warm and not cold. So my thoughts are with Alaskans at this time. We know that Alaska and the Arctic is warming at much rapid speeds, much higher speeds than in other regions. And in Alaska, there's a template and a mosaic of different regions of different temperatures naturally. So the reds in the interior shows that these are relatively warm regions. The Arctic at the top is relatively cold, but there's a patchwork of different temperatures. And so climate is acting on this existing mosaic template of different types of habitats. And anyone who is in Alaska, I gotta move this. Let's get that out of the way. Hold tight. Okay. So anyone who was in Alaska in 2019, we are just now cooling down from this summer that was off the charts, record-breaking hot. In 2019, shattering records. These are anomalies of temperatures in Celsius. So lots of places in the state, 6 or 8 degrees Celsius above normal across the state. And this lasted for extended periods of time. And as I was choking on smoke in Fairbanks from the forest fires, we started getting calls from across the state of widespread salmon die-offs. The pictures on the left are pink salmon in the Prince William Sound region that had entered a stream and got snookered when the water disappeared and died. Picture on the right, the top, chum salmon from the Kayakuk River, major tributary of the Yukon, dead on the shore, and then another picture on the bottom from Prince William Sound. So there was a big pattern that seemed to be emerging across the state. I wrote a sort of hasty paper about the Kayakuk and the Yukon story. My collaborator, Vanessa Von Gila of the USGS, brought us all together, wrote a summary paper that recently is out talking about these patterns of fish die-offs in the face of warming. One of the silver linings, though, was that it shows very clearly that systems that are fed by cold water, in some cases rapidly retreating glaciers, they were buffered by the temperature. And so having this mosaic of different habitats on this landscape does provide options for these organisms on the landscape. And these retreating glaciers are also providing new opportunities and new habitat as the glaciers melt. Under these glaciers are some of the perhaps richest looking salmon habitat anywhere. Whether the ocean will be susceptible or or suitable, I should say, for those salmon is another story, but there's a lot of potential, really good habitat under these glaciers, which raises this question. A student of mine working on this is asking, well, are salmon that are from regions that are too hot in the south, are they the next climate refugees in the north? And indeed, Pacific salmon have been observed, documented in the Arctic Ocean for generations. But just now it's seeming that they are potentially on the cusp of colonizing, establishing. And so my student, Elizabeth McCox-Lindley, is working on this, doing experimentations and working with communities to try to understand what this might mean. It probably is not a surprise that a lot of people on the North Slope of Alaska do not welcome Pacific salmon and often use the term invasive, but are at this sort of crossroads thinking about what does this mean, having Pacific salmon in the far north, which raises to me one of the other silver linings about studying invasive species. So in this adversity, all these issues we're dealing with, there are opportunities to ask fundamental questions. And this goes way back. So Joseph Grinnell, the great naturalist, to my knowledge, was the first that actually pointed to the introduced non-native species as a natural experiment. So here looking at house sparrows arriving at Death Valley as an opportunity to look at population divergence. And this has gone on in lots of literature and books, thinking about these fortuitous natural experiments to understand patterns in nature. Similarly, Herman Bumpus, again with sparrows, was the first that I know of who actually quantified the strength of natural selection by this fortuitous storm where some of the sparrows dropped dead in an ice storm and others didn't, right? And so he quantified the body size of these introduced sparrows and showed, oh, you can quantify the strength of natural selection. That's what he's showing with those little bell-shaped curves that are not lining up on top of each other. That's actually the larger sparrows did better than the small sparrows, okay? So this has built on itself, and one of the insights that comes from invasive species is that evolution can operate really fast. It can operate in our lifetimes. It can interact with ecology. So in fact, two of my heroes studied salmonids that were introduced in places. Andrew Hendry, Mike Kinnison say in their, in my opinion, classic papers that evolution that we had thought of as being rapid might be the norm and not the exception. So I built on some of their work from years ago, over a decade-old paper now, but I actually showed that our understanding in the Western world about the rate of evolution, 84% of these individual calculated rates of evolution that we can calculate come from non-native invasive species. So disproportionately high amount of knowledge that comes from invasive species. And in fact, about 1,100 of those comes from one species alone. So mosquito fish, thank you very much. We've learned a lot from mosquito fish, and Steve Stearns, anyone who knows Steve Stearns, great life history evolutionary biologist, that's Steve Stearns. And about 2/3 or so of the species that are sort of, we understand are native, okay? So we do know something about the rates of native species evolution as well. But the point is, silver lining, we've learned a lot from non-native species in terms of these fundamental questions. And so building on that, during my PhD, I also wanted to use an opportunistic introduction, in this case of brown trout, introduced from Europe to North America in the 1880s, as a way to ask about population divergence, spread, and potentially adaptation to novel environments. So what I showed in a series of papers, there's a citation somewhere hiding under that, these brown trout have colonized many watersheds on the island of Newfoundland. They've spread and diverged from one major introduction of a non-seagoing brown trout from Europe. They've then re-expressed that seagoing life history, moved around the island, setting up shop, so to speak, different populations. And moreover, what I showed through some, I think, fairly fun experiments where we raised fish in the lab and then got permission actually to move fish around in different areas. So we transplanted fish into different streams, tracked the success of those fish, showed that the local trout from their local streams did better, survived more than the introduced trout from other streams, which is really consistent with adaptation to their home environments. And that has evolved in only a few generations in sort of contemporary time. So during that time, what this also became clear to me is that I could be studying evolution adaptation, but really the study of invasive species to me was the study of paradoxes and contradictions. So this is my friend Ken, who helped me with some sampling. He is a transplanted British fellow, and he loves his brown trout. So fishing is not fishing if you're not fishing for your beloved brown trout for a British fisherman. And indeed, they were introduced all over the world by homesick Brits, right? Show up to places like New Zealand and look at the stream and say, my God, this would be great trout habitat, right? What a waste. And they introduced brown trout. So there's things that emerge out of this that are absolutely head scratching and paradoxical. So for example, brown trout that are European, introduced to North America, they bully around native brook trout. Okay? That's not earth shocking. We know that those patterns, you can have competitive advantage, all kinds of stuff. But when you introduce brook trout to Europe, they bully around the brown trout, right? So anyone who has a great idea of what's behind that, there's lots of ways to investigate it. There's some interesting things, but these are some of the head scratching paradoxes. And like good old paradoxes, there's a solution, right? By definition, that's paradoxes have solutions that we can work on. And it does seem like there's some habitat-based explanations for some of these patterns, but that's definitely a head scratching thing. And what this also raised, sort of sent me down the rabbit hole, thinking about the history of these salmonid introductions. So these are species that we all know and love and cherish. And there's a bit of a dark history to this. And it comes from this period of time in our nation's history after the Civil War, when there was a need for national healing. And part of that national healing was to use the new railroad that went across the continent to stock as many fish into whatever water bodies we could find, essentially. That was the mission. So there's a picture, I'm sorry you can't see it that well, but modified railroad cars that had sleeping bunks for people to attend with bellows. People would take turns pumping the bellows to keep fish like shad from the East Coast that were introduced to the West Coast alive. Brook trout went to the East Coast, brook trout went to the West, cutthroat trout, rainbow trout went to the East, right back and forth across the railroad, as many fish into as many streams as possible. And it's a little bit darker. Some people I'm sure know some of this history. It's taken me a long time to get there. And this is something that my students in classes sometimes are shocked by. But a lot of the times, the introductions of these salmonids that are of high cultural value, we all know and love, was preceded by paving the way through rehabilitation, right? Sort of Orwellian speak, for extirpating the native species that were viewed, often the term was as nuisance species. When I think about the importance of the words we use, I'm looking forward to that workshop. So the nuisance species that were native were eradicated to pave the way for non-native salmonids. So this is one of the best examples of a literally military level expedition enterprise to extirpate things like Colorado pike minnow and others from the Green River tributary of the Colorado in the 1950s. The Green River is a blue ribbon world-class trout stream where people can come to catch these amazing things like European brown trout, right? So we're dealing with some of the legacies of this work. And if we think about where Alaska fits into this, this is a history that I did not know. And that's why I appreciate the opportunity to do things like this, because I get to learn new things too. Is that the pattern of paving the way for the stocking of non-native species was not just a lower 48 thing. This was well done, widespread in Alaska, particularly in the 1960s. There's just some quotes from reports. Was that there was major efforts from well-intentioned biologists to create new fishing opportunities. That was the goal. And so quotes like, immediate action plan be undertaken to create new fishing in new waters. Countless landlocked lakes in the area offer an excellent opportunity for management through rehabilitation and stocking of fry. So what is meant by that? There's a couple of lakes here. Rehabilitation means extirpating, in this case, things like native stickleback, okay? That were viewed very much as a competitor species to allow the planting of non-native salmonids into these lakes. Fascinatingly too, these reports show that some of the source strains of those rainbow trout were from places like the Columbia River Basin outside of Alaska. And lo and behold, they didn't survive very well. So the action plan was, well, maybe we should find a local source of rainbow trout to stock, because the non-native ones, right, from the Columbia River don't survive very well. So there's just some fascinating history that I did not know about, I continue to learn about, and I think we're all dealing with. We're dealing with the fallout and the long-term issues of these choices, well-intentioned choices from the past. It was not just in the South Central area, in this area, in the interior where I usually live in Fairbanks. There was rehabilitation through the Rotenone in places like Quartz Lake, which is a very popular sport fishing lake. It was rehabilitated in 1970 and stocked with rainbow trout that are not native north of the Alaska Range. Rainbow trout do not belong in interior Alaska, and it has provided excellent fishing for a growing number of anglers. Okay, and it's still known as a very productive rainbow trout lake. So I'm just gonna, I don't know how much I sped through that, maybe that will spark some conversation, some questions, but I just feel like in the context of the conversations that are going on nationally, this is a good time for us to examine the legacy of our institutions and our roles in them. And so I'm beginning that, you know, with the sort of my sphere of influence that I have control over, right? My lab group, Seek Lab, right? Branded ourselves the university I'm part of, just thinking about what was the past that we are now dealing with in the present, and what do we want our legacy to be moving forward? I've also been spending a lot of time thinking about, you know, what really is the legacy of conservation biology, right? That's sort of the field that many of us work in, which makes me continue to think about, well, what are we conserving and for whom? And so as we move forward, I continue to think that what we ought to be conserving are these relationships between people and place and these resources. In this case, I focus a lot of my work on salmon. And so if there's something that I want to conserve, is the relationships between salmon and people in place for my son, Finn, and others. And at the heart of that, driven by intact, functioning ecosystems free of things like invasive species. So I challenge you all to think about the legacy of your own institutions, how you fit in, past, present, and future. Thank you so much for the opportunity to be here. And hopefully we can have time for conversation and questions. Thank you so much. Thank you, Dr. Westley. We have time for maybe questions. Yes. And if you can speak up.
And like the creation of canoes that actually help to aerate fertilized fish eggs to move up and down with brides up and down the island, because there was a recognition also in strengthening the genetics. And then this sort of also thought of setting the table where you were. So anyways, just to touch on, you know, like that we think that it's these institutions or the colonial past, but we've been moving species a lot longer than that. And I just also wonder how that's come up in research.
Thank you for that question. That's wonderful. I'm sure you know too, I mean, my get friends in Southeast talk about very similar things, right? Moving fertilized salmon eggs in baskets between different streams, doing some of that work. I think the heart of your question is thinking about the time scale of what we're working in, you know, and it's like me going way back here is into the 1960s, which of course is trivial when you think about 10,000 years of people on the landscape. So it's not lost on me, and yet it's also, I have not really gone there. I'm at an early stage of the journey thinking about that. It's come up, the role of indigenous people planting, moving fish around, stewarding those resources in that way, has come up in the work I do, thinking about the role of aquaculture and hatcheries. And how does the modern use of hatcheries, does it continue, is it in the same vein of continuing the tradition of stewardship that was embodied by Indigenous people, or is it something different? And I would argue it's something very different. It's a very different, okay, yeah. So it's come up, but I would love to talk to you to try to work out some of those contradictions and some of those things. I think it would be, it's important and would be fascinating. So I thank you for that. Yeah. Okay. Yeah, we need to talk. Yeah, very good.
Hi, Jackson Gross, University of California, Davis. You bring up a couple of good questions, and I think this is, perhaps a controversial take. But when you talk about looking at our institutions and institutions being more involved in this type of activity, in my experience, the institutions and the academics involved in these institutions are not really interested in solving the problem, but instead studying the phenomena and publishing it. And there are a number of people who are actively involved, and I commend them. But there's a lot of people who will come to this meeting, give a talk, and they'll be gone. And so the question I have is how do we gain that shift and get these people more more into a solution-driven framework versus just studying the history or categorizing the phenomena. What's your thoughts on that?
I think at the heart of that is the training that is, I think, changing. But my training growing up in academia, is that you do objective science, you publish it, and it's sort of separate from the decision makers. If they use it, great, but you do not advocate for any position. You do not advocate even for the use of your work. And I just think that's changing. It's changing in my own laboratory, how we view things, that no, it's not sufficient anymore to give one-off talks, make yourself, get proper and do land acknowledgements, whatever, no, it is our obligation to take our science and advocate for the best available science to make decisions. And so my thought is that I hope it's changing. That it's, I think from what I see, increasingly it is no longer sufficient just to publish papers, get tenure, go on sabbatical, and then show up for a random keynote.
Can I comment on that too? Sorry, I just wanted to add that I also think there's a role in training our students, those of us who are academics. I'm from Portland State, so in that same boat. There's a role for trying to convince our deans and provosts that they should credit us for the work we do. There's a role for invasive species councils to invite more academics in. And I think there's a real role for funders to try to encourage collaborative science and maybe only fund collaborative science. And I know Oregon Sea Grant helps do this, and some of the other funding I've gotten recently has been for collaborative science, and it's really transformative to the scientists and then to getting that science used. So I think it's a great question, and I think you had a really good answer, but I also think there's a role for all of us in trying to make a change to that system, and it's not just like let the academics do their thing, but we can all participate in that. Thanks.
Thank you so much, Sam Chan from Oregon Sea Grant, Oregon State University. What advice would you have for many of us are parents, and also many of us are academics and managers? How would you actually frame this work that you're doing with students so that they can actually, it becomes part of their course of study whether you're an undergraduate or a PhD student.
And this being sort of the history of sorry.
Yes, his history of legacies, institutions, and also the broader impacts of what we do, so that we're not just training the sciences, but there's implication to science and that issue between that fine line between advocacy and science.
Okay, I think how do you train it? I guess it falls under the umbrella in mind of training curious, critical thinkers. That it comes down to not being afraid to look at the history of things, to ask questions, to sometimes question whether you're being raised under some myth story of how things are, and to ask those questions and to not be afraid that well, now that I know this history, I have to burn everything down and go hide. The point is knowing the history and then understanding that it sets the table for where we are at now. That some of the patterns we're seeing now are only explainable based on the history that you may or may not have known. And so it is hopefully empowering students to learn and not be afraid of that history and understand that they're connected to it, and should be forward looking to say, what do you want our legacy in this room and our work to be as we move forward? So I don't know if that answered the question, but it comes down always to empowering creative, critical thinkers.
All right, if you're around later on and you see Peter, please feel free to head him up because science is critical and there's no dumb questions in science, right? And I think that's part of that encouragement. Be critical thinkers. And I'm encouraged by the work we do because removing invasives or controlling and preventing them in the wake of climate change helps restore those habitats for native species to make us more resilient in that fight. Now we are going to move on to our next session, Alaska Perspectives on Invasive Species, and Tammy Davis, our gracious host, is going to lead us in that discussion and turn it over to you. Now, which one's yours? No, that's actually not it. Which one are you?
Dunker.
Dunker. Okay.
Good morning, everybody. Thanks again. It's been my honor to work with the planning committee to bring you all to Anchorage, Alaska this year. It's so wonderful to see your faces in a room and not just a virtual room. I am also delighted to share with you talks about Alaska and what it's accomplishing. Christine Dunker will be our first speaker, and I've had the pleasure of working with her my year as an AIS coordinator. She's a delightful person, and she will be on our field trip on Friday. So while we might try to catch up some time here during Q&A, Chrissy is going to be available on Friday and throughout our meeting. So please reach out to her. She's the Invasive Species Coordinator for the Alaska Department of Fish and Game's South Central region. She's been working with her team on invasive northern pike management in Alaska for the last 16 years. Welcome, Chrissy.
Okay. Cool. Okay. Good morning, everybody. Thank you for having me. I am going to talk today about what I consider to be a pretty cool invasive species success story, and that is eradication of invasive northern pike from Alaska's Kenai Peninsula. There we go. Okay. But first, just a little bit of background, especially if you're not familiar with northern pike. They thrive in habitats that look a lot like this. They like shallow water and not a lot of flow, and they need a lot of aquatic vegetation. And in these places, they are at the top of the food chain. Now, one of the things that we've noticed with introduced populations of pike is that there tends to be a pattern where they'll prey on salmonids or fish prey first. They're very opportunistic in their feeding otherwise. But they'll typically go after fish, and once those populations are depleted, they'll shift their diets onto invertebrates. This causes a predator like pike to stunt in their populations. And that's kind of an unfortunate but reality of what ecologically happens when they're introduced. But typically, pike will hang out in kind of the vegetation, the aquatic weeds, wait for their prey to come by, and then they've got a very quick burst speed after them. And this striking behavior makes them a very popular sport fish. That is part of what has made their management and their story here in Alaska kind of complicated. But the other part, as Tom shared this morning, is that pike are actually native to most of Alaska, and this really does make it complicated. So here, everything in the hashed area shows their native range in Alaska. Well, basically, this here would be the Alaska mountain range on the border of that. And so everything south and east of the Alaska range shows where pike are not native and have been introduced, and that's all the solid red areas here. So this problem in Alaska began decades ago, in the late 1950s, through illegal introductions. And today, pike have spread to over 150 water bodies in South Central associated with the drainages on this map. But where we're talking about today is the Kenai Peninsula. And on the Kenai, introductions began in the 1970s. So this map kind of zooms into the Kenai and shows all of the infestation sites on the peninsula. And the first spot that we believe pike were introduced to was Dirks Lake. This is part of the Soldotna Creek drainage. So this entire drainage is a tributary. It connects directly into the Kenai River, the world famous Kenai River when it comes to fisheries here in Alaska. And unfortunately, for decades, not much was done about this. And ironically, this was occurring during the time that Peter shared with us, where we were removing sticklebacks and other things for stocking programs. But around the time that pike were first introduced, biologists were alarmed, and they even considered trying to remove them. Unfortunately, by the time they kind of got their project plans together and their permits, Dirks Lake had froze, and they believed it was an open system. It was too late. So they abandoned their plans, and these plans would not be brought up again for about another 40 years. Does not want to move again. Okay. There we go. But in that time, pike spread from that spot in the Soldotna Creek drainage and were illegally introduced to several other places on the Kenai Peninsula, eventually totaling about 24 separate infestations. By about the 1990s, concern about this really started to grow. We were learning things. We were learning more about their distribution, their movements, their diet patterns. And as the research continued, it was becoming quite clear that we had a fairly large problem on our hands. and that pike were a culprit in losses of native fish populations and fisheries. We were also learning that the impacts that we were seeing weren't uniform. And we hypothesized that habitat is a major player contributing to the differences in impacts that we see. So where pike are native in Alaska, they're often in these very complex glacial systems, really deep lakes. So where pike might be kind of a dominant player in sort of the wetland areas, they're not going to be in the deep lakes, and or at least not in numbers that'll be affecting other fish as much. So there's places for other fish to avoid them. Now, in other parts of their native range, if the ecosystem is all shallow habitats and marshy throughout, pike are still an apex predator, but they just have naturally shaped the fish communities that are found there over time. Now, on the Kenai Peninsula, we have plenty of the same shallow marshy habitat everywhere, but naturally, in the absence of pike, these ecosystems function as coho and rainbow rearing habitats and are really important for that. But pike introductions change that. And we saw that happen time and time again on the Kenai Peninsula, where popular fisheries, native populations, were basically extirpated and replaced with stunted northern pike. So in an effort to kind of change that trajectory, we began invasive northern pike efforts in the early 2000s. Now, in the beginning, these efforts were fairly basic. They involved really increasing public outreach, trying to get the word out that moving fish around was illegal, that pike were problematic here. Also, we liberalized harvest, so there are no limits for the number of pike that you can catch. Today, if you catch one, it's actually illegal to turn it alive. You have to kill it. We installed temporary barriers throughout the pike waters on the peninsula in an effort to try to contain the pike populations. And in the beginning, we began annual control netting to try and reduce their numbers. But it was quickly becoming obvious that if we really wanted to get ahead, we had to do more than just thin populations. And so we knew we had to start eradicating populations. And there's not a lot of options for how to do this. As we've heard a little bit discussed this morning, the best option is through using a fish pesticide called rotenone. And rotenone, as you've heard, has been around for a long time. It's, you have to be careful with it for good reason, but when used appropriately, it does not have long-term environmental impacts. That said, there's a very extensive permitting process for using rotenone. For all of our projects on the Kenai Peninsula, each one took between 1 and 2 years to permit. And then the field process for projects from pre-treatment planning all the way through conducting treatments to any of the post-treatment restoration work is all very, very involved. Each of these is a multi-year process as well. But when we started this work, trying to eradicate populations, we started out pretty small. At the time, there wasn't a lot of belief that much could be done about the pike situation here, that it was too late, that maybe we could reclaim some hatchery stocked fisheries, get rid of some source populations. But that was about it. We really weren't shooting too high in terms of what our goal was at this point. But with that in mind, we treated 2 lakes. One was Ark Lake in 2008. That was our very first treatment. And the other was Scout Lake in 2009. Again, both closed small lakes. And these treatments were successful, and we stocked both of these with rainbows and coho. And they served a couple of purposes. And starting out small, our team was learning how to use rotenone appropriately, and also trying to gauge kind of public acceptance of this approach. Around this time, 2 more pike populations were found. Luckily for us, both of these were pretty small ponds, pretty low density populations. And we were able to knock both of these out just with gill nets, which was kind of a nice opportunity to try that out. So that happened in 2011. And with these successes kind of under our belt, we started to think, well, maybe we could do something here that could actually benefit wild fish and do a little bit more. And so that's had us stepping up our game to a much larger lake on the northern Kenai Peninsula. And this was Stormy Lake. And this lake was very different from our first two treatments, much larger, quite deep. And it also was in an open system. So it had a connection to the Swanson River drainage, which is all great pike habitat. And we were very concerned that pike would eventually colonize this. We actually blocked their access for about 12 years with temporary barriers and bike nets. But this ended up being, at that time, our biggest project. It was also the first time that we had native fish still surviving in a place we were looking to eradicate pike. So this involved a really large effort to kind of protect those fish. In fact, the largest Arctic char populations on the Kenai occur in Stormy Lake. So before the treatment, we collected as many of those as we could, actually raised their brood stock in our hatchery while we were doing the treatments. And after the fact, when the rotenone had dissipated, we were able to put back 7,000 fingerlings of these char. In addition to that, we rescued as many native fish as we could out of there and held them in net pens in a neighboring lake until, again, we could put them back. So the treatments were a lot more complex. Again, first time in an open anadromous system. This required backpack sprayers and airboats to treat adjacent wetlands. We had to kind of rig up our own deep water delivery system for the rotenone. And for the first time, we had used drip stations to treat kind of flowing waters in the area, as well as neutralize the rotenone, which you can do with potassium permanganate. And this was our first time doing that, so it wouldn't enter the Swanson. Stormy Lake succeeded. The pike were gone. The native fish restoration happened. And we started to legitimately think we've got a shot at eradicating pike completely off the peninsula. This was contingent on our ability to get them out of the Soldotna Creek drainage, which was the place where this all started and where 40 years ago, we kind of walked away. So this project was a biggie. This involved basically splitting the entire drainage into two large sections, basically with, again, those temporary barriers. Now, the first part of the drainage, the western branch, did not have anything left other than pike, not even sticklebacks. Everything had been eradicated or extirpated by them. Now, this other part of the drainage, the second half, what we call the eastern portion, did have native fish still. And a big part of this project involved trying to rescue those. So this project took 4 years to complete and to treat. Again, the most extensive and difficult treatments we had done. A lot of it had to be done by aerial spraying. In the end, we ended up treating about 500 surface acres of lakes, about 150 acres of wetlands, and 20 miles of main stem Soldotna Creek and its tributary streams. But the coolest part really was doing the restoration work associated with this. So in 2015, between treatment years, we reallocated our efforts to going out and trying to rescue as many native fish as we could from the part of the drainage that still had them, and then relocating them into the part of the drainage that at this point no longer had pike. So in total, between 2015 and last year, we've relocated over 95,000 native fish to recover those populations. And then it came down to one last project, removing pike out of what we considered the tote road area, which is the Soldotna. And this was a series of 8 lakes that were relatively simple closed lake populations. We treated those in 2018. Now, interesting aside, while prepping for this project, we discovered that one of these pike populations didn't quite look right. And we quickly determined that's because they were actually musky lunge that had been illegally introduced. We genetically tracked them back to Wisconsin lineages. So someone went through the effort of moving these muskies from that far away. But in the end, muskies, pike, they were all eradicated out of those lakes. And it allowed us to move on to the fishery restoration aspect, which is still ongoing. In this case, there weren't any surviving native fish. These lakes also don't have public access. So stocking with our hatcheries is not an option here. So we have been relocating fish from nearby creeks into these lakes, and we'll be doing so for another few years. So that was it. Yay, we had accomplished our big goal of eradicating pike off the peninsula. We reveled in all of our glory of having done this impossible thing for about a week. Until pike were reported by an angler in a remote lake in the very northern tip of the Kenai Peninsula. Turns out that angler was right. Pike were found in Vogel Lake here in red on this map in the spring of 2019. So this was a bummer. This whole area is all great pike habitat. It also connects into the 7A drainage, which is all more of the same. So that summer, we joined forces with Fish and Wildlife Service and launched this huge expedition to try to find the distribution of pike out here. And luckily, the beavers had been our friend, and there were a lot of beaver dams, and the pike populations had been contained to Vogel Lake and North Vogel Lake. So this was good. We learned that we weren't too late. We also learned some things that weren't such good news. If you look at this is a whole presentation of itself, but if you look at stable isotopes using the otoliths, which are the ear bones of fish, you can get a sense of what kind of environment the fish spends its time in. So we did that with our oldest fish from Vogel Lake, and we found it had a pretty obvious marine signature. So in this case, this fish started its life in fresh water, spent some time in marine conditions, and ended its life again in fresh water. So in other words, this fish could have been flushed out of its Susitna River, about 20 minutes to the north, and spent some time in the estuarine waters of Cook Inlet before nosing its way into Miller Creek and then into Vogel Lake, which would have had to happen twice because we had a population of different age classes. So in order to have a reproducing population, that must have been the case. So not good. And we have since completed some salinity trials and been able to verify that pike can survive in salinities that are representative of northern Cook Inlet. So the original, that was kind of put on hold. It's a problem, but our original idea was we needed to get in there and rapid response, get rid of these pike. And so in 2020, in partnership with Fish and Wildlife Service and Watershed Forum, we got all the permits and the plans together to treat it in 2021, last fall. Again, being caught early, these lakes still had native fish. So for the weeks prior to treatment, we collected as many of those as we could to fly them out of harm's way. And the treatments themselves were pretty complex, owing mainly to the very remote nature of this area. It was also happening under COVID, adding another layer. But in the end, we got it done. So since then, the treatments were determined to be successful. No pike have been found. And so we've removed all the temporary barriers in the system so that fish can recolonize. All but one of these barriers. There is one in place in Miller Creek. This is a weir, and it's our only line of defense right now against pike returning the way that they came. Not easy. This is a really remote area. It's hard to access. Maintenance is difficult, but it's all we've got. And in a year, our funding for this project runs out and this weir comes out. Well, so then what? Well, the answer is we honestly don't know. We are asking some pretty tough questions right now, trying to figure out what to do about this. We had a grad student just recently finish some research at UAF trying to look at the physiological limits of pike, see if there's something their leaping ability that could be exploited potentially to develop pike-specific exclusion barriers. We don't know if that's possible. We're just scratching the surface trying to ask these questions, but we are asking them, and we're trying to get funding to do some more work. But today, with what we know, for the first time in 50 years, the peninsula is pike-free. We know there's an ever-present risk of them returning, either through the Cook Inlet situation or bucket biologists. So we will always be monitoring for them. We're not walking away. And just this year, the Northern Pike Committee through the Alaska Invasive Species Partnership completed a very extensive management plan, technical guidance document, basically informing everything invasive northern pike related in Alaska. It's online. If you want a copy of that, though, I can make sure that happens. And with that, I would like to thank our many partners and funders. And specifically, I'd like to call out Rob Massengill. He is our fish and game biologist who will be retiring this year, but was truly the mastermind behind all of this work. With that, thank you.
Sure, well, we do a quick switch.
Sure, I mean, all sorts of things, lots of presentations, lots of, public events, and anytime that there's like a fishing forum or a show, we've got, a booth, we've got people there talking, to anglers directly. We have a pretty extensive website on all of this. Every time we do an eradication project, it involves a public process. So lots of mail outs, eventually public meetings. And so these are all individual opportunities to engage with, local residents, about it. Print materials and all those kinds of things too. We've got YouTube videos, all gamuts of outreach. Dr. Gross?
I think you downplayed the challenge of working in the environment. I mean, I've been all over that environment, the floating bonds and the, I don't think, Herculean effort. I don't know if that is even appropriate, whatever is above that. But people don't realize the amount of the challenges of working in this area, and it's amazing to hear like together
Like 2007, yeah.
Yeah. So is that really that long? Oh, yeah. Anyway, yeah. So I mean, it's just like crazy to think about. I guess you have a child to document this. So yeah. So anyway, just I want people to realize the amount of effort that this was, and the continuous progress and steps forward, and the unrelenting nature of it. So anyway, congratulations.
Thank you. Appreciate that.
Next up, we have Aaron Martin. Aaron is originally from Idaho, and he did his studies in Montana and at the University of Alaska. He's currently the Regional Invasive Species Program Coordinator for the U.S. Fish and Wildlife Service here in Anchorage. And anybody who does invasive species in Alaska works with Aaron on some capacity, and we all are appreciative of that.
Good morning, everybody. Like Tim said earlier, it feels really good to see you all here. I love sharing the place we live with everybody. So I'm really thankful that you guys all took time from everything to be here. A little flashback to Tom's presentation earlier. He and I used to cross paths quite a bit when we both worked on Yukon River salmon management issues for subsistence efforts there. We both worked with this older fisherman and always had this adage. He was a commercial fisherman, but also subsistence. And time again, we'd be at these international conservation meetings, and he always laid out the 7 Ps for us. I don't know, Tom, if you remember who I'm talking about, but he kept saying proper planning and preparation prevents piss poor performance. And I channel that still in Virgil. It's on. Yeah, that was a classic. Some folks that may have spent time in the military may be familiar with that term for other purposes, but I channel that a lot for our jobs here. And talking about reflecting on Peter's conversation and presentation, I mean, our legacy doesn't bode very well for what we need in Alaska. We have not been investing internationally in prevention and planning as much as we should be, could be, can be looking forward. This is a recent paper from Cofford et al. That came out this spring, really laying out the difference on pre and post invasion investments and our investments into better decision making and understanding prioritization of our resources and what species we should be focusing on. And the data here is a little bit out of date, but Dr. Toby Shore did a similar analysis about a decade ago, looking at federal, state, tribal industry investments in Alaska. And I modified the data a little bit to kind of follow the same bins that Cofford et al. Followed. And we have the same pattern, investing in post-invasion more than anything else. And I think there's a trend changing nationally. We've got QZAP 2.0. We've got a lot of bipartisan infrastructure law money with emphasis on prevention and knowledge. We have a long way to go. And I certainly feel like for Alaska, it's fortunately where we are, and investing in prevention and in making better informed decisions is where we need more and more investments, because you guys are all, many of you all are helping prevent things from getting here, and we're trying to draw the line in the sand or at the border to keep things from getting out here, so we don't end up with a 50, 60-year-old decade issue. So Alaska is an extremely complex state. I'm not going to overlay it over other states. Everybody's seen those graphics before, but Fish and Wildlife Service alone owns 76 million acres in Alaska. 75% of all the National Wildlife Refuge land is in Alaska. This huge complex landscape with a lot of state, federal, tribal jurisdiction, and it requires that we work hand in hand to prevent and eradicate invasive species. And we're having some pretty incredible success stories. Some food for thought, though, is just recognizing all the different entities that are affected by invasive species, from our Alaskan Native communities and the hunting and fishing, fishermen, wildlife viewers throughout Alaska. Huge, huge industry for Alaska. And most people, when they step back and think about Alaska, there's often like fishing, but also from our extraction industries, logging and oil extraction, gas extraction. But some of our biggest economies are driven by our aquatic resources, our renewable aquatic resources. And from an infrastructure perspective, there's a lot of talk in the national scene about infrastructure. Alaska's infrastructure is pretty incredible, even though we only have a little bit of road. So much of our transportation is reliant on our waterways and our water bodies to move people around. Similarly, we actually have hydropower facilities in Alaska. I don't think we get recognized for that. Most of it is in southeastern Alaska, but one of the biggest dams in Alaska is down on the Kenai Peninsula and providing hydropower to much of the Kenai Peninsula. So trying to address things beyond just our fisheries issues, but also our infrastructure capacity and the resources that we rely on is really important. Recognizing that the Fish and Wildlife Service here has taken a really great approach. I pat ourselves on the back, and I appreciate the support that everybody else has been giving us too. We've identified invasive species as a regional strategic intent, a priority for our region, to really lay down our resources on invasive species and try and get ahead of it before it becomes a much bigger issue. Similarly, we've made formal commitments across our programs. We've made a unique decision to combine our programs across our refugees program and our fish and park conservation program and our ecological services program to unify our limited resources to amplify what we can do. And with that, a huge part of our story has been reliant on this amazing partnership that is growing at an exponential rate right now. It's kind of, I complain to Tammy a little bit every now and then. I say, can't keep up. We're going so fast. It's so exciting, but I don't want it to slow down because of all the progress, like Chrissy's presentation and the Northern Pike, the new Northern Pike Management Plan. Huge kudos goes out to Chrissy on that lift. That was an incredible effort, and it set us up. And there's more and more synergy like that happening through these various committees, and it's really, really exciting. And we're about to finish our first community-wide, partnership-wide strategic plan this fall. We're coming into presenting that at our annual workshop. So a lot of momentum through the Fish and Wildlife Service and our partners through this partnership. And Danielle, thank you, and everybody else that's involved in the partnership. Thank you for your commitment to that. And it takes a lot of time, but we're having incredible successes there. One place that I feel we could use more support and more engagement at a national level is our involvement through the Arctic Council's Arctic Alien Invasive Species Strategy and Action Plan, or the ARIAS. We had a lot of momentum about 4 years ago, and then due to shifting priorities at the federal level, we lost a lot of momentum, and we need that back, because we have a lot of local momentum and a lot of synergy through the Western environment here through platforms like this, but having that international circumpolar discussion about how we can prevent new invasions, how we can contain things that are in the Arctic in the places that they are. We are really fortunate. I will continue to say this, I feel like a broken record, but for the most part, we are in the far corner of the invasion curve. There are a few species that are starting to creep up the invasion curve, but for the most part, this is where we are, and this is where we want to be. And we're showing successes like the northern pike issue, but also other aquatic invasive species. So reflecting back on those graphs that I showed, the service is really dedicated, and I know a lot of other folks in our partnership are really dedicated to balancing the scales, like trying to get more balance to the pre-invasion side of that, to the other side. I don't know, should we invite Sylvia? Come on in, Sylvia. So we're trying to get more support and people out on the ground doing invasive species early detection work, but we're also really trying to lean into our prevention efforts. Understanding risks is a really high priority for us, and I apologize, the map's really bleached out from the lighting, but in the background is the border of Alaska, hopefully. We have a paper in press that Tammy helped with, and other partners from the University of Alaska, trying to understand the risk. A lot of us talk about risks of watercraft moving on the roadways. For us, a unique challenge is watercraft going to Port of Tacoma, Port of Bellingham, going to San Francisco Bay, and then getting barged to Alaska, never touching an inspection station, never getting asked, where did you get used last? We had no idea on the level of risk of a boat coming here. So we teamed up with Toby Shore and others to try and fit into that. Like, what is the risk of a boat coming here compared to a boat coming on the marine highway system up southeastern Alaska, or on the one major highway on the Alcan Highway coming in, where we do have an inspection station. And this was all from 2017 data, when we had some pilot work at our Alcan watercraft inspection station. So that the results are maybe a little skewed, but it certainly helps us emphasize that there's a lot of watercraft coming in other ways besides the road system, and that we need to lean into those ports of entry. So thank you, Robert, for helping me with this. Unfortunately, we need to update the Colorado map, and but this is our data from our watercraft inspection station this year. We've got 3 years of data, the last full seasons, and huge kudos goes out to U.S. Customs and Border Protection. The Fish and Wildlife Service, through the Lacey Act, works really closely with them to do watercraft inspections, because it's an international port of entry. And we had record number of boats this year. The last 2 seasons were our first full operations, but it was really reduced because of COVID restrictions, travel restrictions. And this year we had 670 boats or so come through the border between May and the end of August. And you guys can see where they're coming from. It's coming from all over the country, and people are flying to Florida, grabbing a boat and driving straight to Alaska in 5 or 6 days. That's how boats are getting brought up here. Primarily used boats. We're getting trailers of 50 brand new Hughes crafts, upside down and clean as can be. And so some of the numbers are underrepresented here of the total here, but huge kudos goes out to the project manager for this, Mike Buncher. I'm not sure if he's in right now, but he's been doing a fantastic job leading this project, and we're hoping to continue these operations into the future. Another really awesome success story is around Elodia. Not that it's here, that it's not a success, but I think we've been chasing Elodia for 20 years or so, and in the last 10 years, we've gotten really a lot better about finding it and eradicating it, and understanding the potential risk to our resources here. Toby Shore, Dr. Shore did some research understanding the impacts of Elodia on sockeye salmon fisheries alone, but ignoring coho and pink salmon and king salmon, gum salmon, just sockeye salmon fisheries. And from a commercial side of things, he estimated $158 million loss to the sockeye salmon fishery a year if Elodia continued to spread. Compare that to the amount of loss on an annual basis to commercial fishing, recreational fishing, and water use resources in the Great Lakes through shipborne AIS. So a little bit of doom and gloom there, but I think the real positive is that this year, oh gosh, knock on wood, across our partnership, we have surveyed over 100 water bodies throughout Alaska, state, federal, tribes, industry, all engaging on this. And no infestations have been found this year. It's a huge win for us. I bite my tongue there. And all the known infestations are under treatment, which is another huge success for us. We've got some water bodies in the Copper River Delta that we need to continue to figure out how to address so they don't become sources to treated areas. But we are, I'm not going to say winning, but we're catching up. We've been chasing it for a long time, and we're catching up with the Elodia issue. And part of that is through raising awareness. Like somebody asked earlier, is we've got a lot of people communicating through partnerships. The Fish and Wildlife Service has an outreach and education invasive species coordinator, and we are really leaning into raising awareness. So where do we want to go? We want to continue to fill some of these critical control points. I highlighted the Port of Bellingham, so continue to talk with Washington State, our partners in the Pacific Northwest about how we can fill some of those gaps. Anchorage, the Port of Anchorage, right below the hotel here is where all the barges are coming in and offloading the majority of the watercraft into Alaska. There we go. Better understanding the distribution of quagga and zebra mussels and understanding the potential impact of quagga and zebra mussels if they get here. So Tammy, thank you for your efforts to lead that effort to prioritize water bodies for surveillance. But we are really deficient on abiotic information throughout Alaska, given its remoteness and how many water bodies we have. Just we are lacking information on calcium and pH that can really help us prioritize where to look and where to put early detection efforts and outreach. And as Christy identified, trying to understand more about northern pike, where they're going, how they might be moving around, and how we can help prevent that spread. Tom mentioned he mentioned signal crayfish in the Buskin watershed. The Fish and Wildlife Service has been working with USGS and the University of Alaska and the Sunyak tribe of Kodiak and others down there to better understand the distribution of signal crayfish and the potential impacts on the subsistence sockeye salmon fishery there. Certainly need more resources dedicated to that. And then as Linda will hit on, increasing support for the emerging European green crab issue in southeastern Alaska. Alaska has over 34,000 miles of shoreline around all the islands and around the mainland, and it's a lot. That far outnumbers the entire shoreline of the 48 states. So trying to get more surveillance throughout those areas, priority ports. Dutch Harbor is the busiest seaport for commercial fishing in the United States as far as how much income, but we don't have eyes and ears there looking for things like European green crab and other things coming from Southeast Asia. So trying to build out our network with our tribal communities and our federal partners. So before I close, I just want to, how many people, is this their first time to Alaska? I love that. Thank you for taking time again. How many people have eaten king crab or salmon in the last 48 hours? I love it. Those are the things that we're here for, right? Like that, I get emotional about it because I fear that those things are going to continue to dwindle, and we are seeing repercussions like Peter alluded to. These changes in water conditions are really harming our salmon runs, and they're harming king crab runs. King crab harvest in the marine environment is one of the lowest on record the last couple of years. So hopefully you guys used your full per diem on that. But we have a huge opportunity to continue to have successes in Alaska around aquatic invasive species, and it requires more planning, more preparation for good performance. So Thank you, Tammy, for the opportunity. Thank you, everybody. I'll be here and I'll be on the field trip. Follow up. Thanks.
Yeah, so while I do this.
Eight seconds, I think, is the magic count before you move on. Yeah.
On that, with your collaboration with Fish and Wildlife Services, is that still going on, or we've identified that Elodie is the #1 that transports on seaplanes?
Elodie moves in a variety of different ways. It's moving on our watercraft. It's moving, unfortunately, in giant ice jams. It gets frozen in ice and then picked up during the spring and moved downstream hundreds of miles and shows up in places where we don't ever really expect because there's not much recreational or subsistence use in those areas. The Fish and Wildlife Service, Dr. Tour worked with the Fish and Wildlife Service and a bunch of other folks to do a plane vector analysis here to understand the magnitude of movement of water floodplains in Alaska. Susan Pascoe with Fish and Wildlife Service headquarters can talk more about the national RFP looking at the floodplain assessment that's soon to be taking place. I think we're trying to finalize somebody to do that project, right? So.
Thank you, Aaron.
Okay. Cool. Phase 1 has been awarded. Phase 2 has been pending, is what's been said. So, thanks, Steve.
Thank you.
Great, thanks. Thanks again, Aaron. Yeah, Aaron will be on the field trip also on Friday. And if you have questions about Anchorage, Alaska, etc., Chrissy and Aaron will have lots of, especially for Anchorage. Our final speaker of the session is Linda Shaw. Linda has been a habitat biologist with NOAA Fisheries, Alaska region in Juneau since 1991. She was part of the original team to discover Didymophyllum, colonial tunicate infestation in Whiting Harbor. Chrissy and I were also there. We made a dynamic team. Welcome, Linda.
Thank you so much. So we're going to switch to the marine environment. And this is a story of a collaborative partnered effort that started as outreach and monitoring and unexpectedly and recently led to the discovery of, sadly, the first population of invasive green crab in Alaska. And I would like to say the lead partner on this is the Metlakatla Indian Community Department of Fish and Wildlife. I'd like to acknowledge my co-authors, Taylor Stump with the Metlakatla Indian Community Department of Fish and Wildlife, and Barb Lake with NOAA. And NOAA's role in this has been to provide funding and technical support. So just a little bit on invasive green crab first. They're also known as European green crab. Their native range is Europe from Scandinavia to Northwest Africa. They have invaded many continents across the world. And they first showed up in North America in the 1800s. They are thought to have gotten there through ballast in ships. They jumped to the West Coast in the late 1980s in San Francisco Bay. That was thought to have been through bait shipments. And they've been moving south and north. They tend to jump north with El Nino events. They're identified by 5 spines on either side of the eye and 3 bumps in the middle. They are not always green. They can be yellowish or red. They're only about 4 inches across the carapace width when they're fully grown, and they are considered one of the most invasive species in the marine environment. Okay, so we have known that these guys were potential invaders to Alaska for quite a while. And in recent years, that has become even more of a threat because in Washington state, there have been emergency and disaster declarations made by the state, Lummi Nation, and Makah tribe. We were hearing these incredible increases in numbers recently, 5,500% increase in Puget Sound from already hundreds of thousands of crab being caught. On the west coast of Vancouver Island, just since November 2021, they've caught 300,000. This map shows monitoring efforts and whether green crab were caught or not. And if you look at this map, you can see that the closest up until our discovery to Alaska was Haida Gwaii Island off British Columbia. There was also a report of larval green crab in Prince Rupert. So they were getting close, but there's also a lot of monitoring up there that doesn't particularly show them. So we thought, and we're hoping that we had a little more time before they showed up. And the dots up at the very far north, it's hard to see and I apologize, but that island is up there in the southern part of Alaska. And so Haida Gwaii is like about 100 miles from the border. So this slide shows photographs from the discovery site in Tamdis Harbor on Annette Island. And I wanted to use these photos to highlight the resources at risk in Alaska from green crab. So this area had extensive eelgrass beds, and green crab will burrow into the sediments of eelgrass beds. They will both uproot and mechanically damage eelgrass as well as stir up those sediments so that it settles on the blades and they can't photosynthesize as well. This is a really interesting feature. It's a Klingens fish trap that is they're ancient and have been used, culturally by Native Americans in Southeast Alaska. There's a salmon stream up there, and then these rocks lead the salmon at higher tides into these pools where they could be caught. And we found quite a number of crabs in those. Also, this area is very productive for clams, Dungeness crab, red rock crab, and this is a larvae that we found that we got it identified to either a red rock or Dungeness. So it's a rearing area for Dungeness crab with which European green crab compete. And we even saw little mink. Okay, so anticipating that green crab could be coming to Alaska, this project has been in a partnership since 2020. And it's with the Metlakatla Indian community, which is about 70 miles south of Ketchikan, and the only Native American reserve in Alaska. They manage one of the largest salmon fisheries that are non-state managed. And so this is a picture of Annette Island, and this is where we found Tamdis Harbor. So our efforts started out with supporting trapping, and so Metlakatla Department of Fish and Wildlife has been using both folding fukui traps, and then later, when others started experimenting with shrimp pots, they also started using those. They use boats for deployment, and they put them out in an anchored arrays of 5 for 24-hour soaks. And They've been doing this since 2020 and hadn't caught any crab. We also were incorporating eDNA sampling to see if that could be an early detection tool. And that was delayed in 2020 because the supplies that are used for this are also used for COVID, and we couldn't get them. But we did get samples in 2021. Those have been sent to Ock Bay Lab, our contractor with Ock Bay Lab, and they recently were analyzed, and there was no detection. We also opportunistically got some samples from Leah Domke, who's doing research on fieldgrass wasting disease in southern Southeast Alaska. So those were some sites beyond Annette Island, and those also did not have any detections. Now for 2022 and 2023, we have a contract with the Army Corps of Engineers Lab in Vicksburg, Mississippi, and we've collected some samples for that. Those are actually in process right now, and I'm expecting to hear those results in a couple of days. So those will be very interesting because the samples were collected from the area we found the green crab. So it'll be interesting to see whether they detect them. So we worked with the University of Washington APHIS program to produce these signs for Annette Island Reserve that are customized for the Metlakatla Indian community with their logo and their phone number. And they were placed throughout the island, and the messaging is find it, keep it, freeze it. And so you can see the sign there with Roger. These are some of the carapaces we found as we're talking about later. Okay, so the discovery and how it unfolded. So myself and Barb and a Sea Alaska Heritage Institute intern, Natalie Bennett, traveled to Annette Island in July, and Natalie was someone who, this was the first year for the Sea Alaska Heritage Institute internship, and Natalie was asked what kinds of NOAA topics she might be interested in, and much to our delight, she said green crab. So we brought her along, and it was part of her summer project. And our intent was just to go and meet the people, the staff, and see our signs, see the locations where they were doing monitoring. And so we got to Annette Island, and Taylor picked us up, and he said, well, you guys want to do some carapace surveys? Which is something they hadn't been doing, but seemed like maybe, a good activity for these visitors, right? So we went to one site, we started doing carapace surveys, we were looking at the rack lines, and we didn't find anything. And then we went to the second site, and I was looking at rack lines, but Natalie was looking up rather high. She was looking up in these grasses, and up there is this sign and these grasses. And lo and behold, Natalie found this carapace in here. And as it turns out, there had been high tides and storms the week before. And so it must have pushed these carapaces really high up. And we were really surprised and asked Natalie, why did you think to look that high in the intertidal? I mean, that high up beyond the intertidal. She said, well, my uncle always taught me to look high. So it's really an example of traditional knowledge that's being passed through generations coming into play in a real way in the discovery of green crab. And of course, we were all kind of like shell-shocked and totally didn't expect it. But we kept looking. Roger found another one up on the road, and it changed the whole trip, obviously. So I haven't seen a lot of the other sites that they're monitoring on Annette Island, because then we just started focusing on this area. And so just launched an intensive trapping effort there in Klingens Harbor. As of September 15th, this is probably different now because they're going out every day, but they've caught 121 live crabs. They've found 21 carapaces and 8 dead crabs. Now, 2 of those dead crabs were found in this area, Smuggler's Cove. So here is Klingens Harbor, where the big population is, 2 dead ones over here. So unfortunately, that probably means that there are green crab in some other areas. They aren't limited to Klingens Harbor. So Taylor was able to collect tissue from 20 live crabs and send them to Carolyn Teeple, who will also be speaking at this conference. And this is great because the population genetics that Carolyn does will be a little more detailed information than the eDNA can provide and might give us some insight on, oh, I got the warning, on where they came from. So I'll just quickly go through this stuff that look for carapaces. That's how we found them. We didn't expect that. The fukui traps are maybe not as good as the shrimp pots. They haven't actually caught any on net. The shrimp pots are doing a better job. I want to make a note that outreach messaging is different off of a net island because of state regulations are different. You cannot possess a green crab or its parts. Tammy did an effort looking around Ketchikan in September and did not find any. Metlakatla was going to go all season based on information they've gotten from other tribes in catching them in the winter. Fish and Wildlife Service is funding a facilitation effort. There's a national effort by the task force, and we are reaching out to British Columbia for cross-border communication. I don't have time to read this, but it's a great statement by Metlakatla Indian community that is basically saying we're all in this together and we need to partner and stop this invasion. Thanks.
Maybe 1 or 2 questions. Yes, Peter.
Green crab, will sea otters maybe be a barrier to spread in establishment? What are your thoughts?
I think it's an excellent question. So my understanding is that sea otters have been documented to eat green crab from Elkhorn Slough in California, and I believe there might be some other evidence from Washington. So the distribution of sea otters in Alaska is they're not terribly abundant in this particular area, although one of the MIC DFW staff said that he had seen one around there. Yeah. Well, they're probably going to move in, and it could come and display into other. There are very abundant otters in other parts of Southeast Alaska, where it could be a factor.
All right, thank you, Linda. We are going to take a break. Let's try to do 15 minutes instead of 22. A little bit closer to 50. And please commiserate with your friends, and we'll start back up in 15 minutes. Thanks, everybody. All right, welcome back from break. We're going to start the next session. Actually, let me get my. All right, yeah, my name is Chris Shiani. I'm the program manager for the Marine Invasive Species Program from California, and one of the co-chairs for the Coastal Committee here at the WRP. We're having a Coastal Committee meeting tomorrow afternoon, so anybody that's interested, just please show up. All are welcome. But today, it's my pleasure to introduce the speakers for the Coastal Perspectives on Invasive Species session.
We have 3 great speakers with a slight change in the agenda. Alan Ployce was supposed to go first, but we're going to push him towards the end of the session. So that means Carolyn Teepolt is going to be our first speaker. She's an associate scientist at Woods Hole Oceanographic Institution, and she's going to be talking to us about tracing sources and dispersal pathways in marine invasive species using genomic tools.
I can't do it upside down.
All right. Thank you, everybody. I'm delighted to be here. This is both my first time at this meeting and my first time in Alaska. Take this down so you can see my face. Yeah, I'm thrilled to tell you a little bit about some of the research that my lab does. Okay, I'm told I need to hold this closer. Better? All right, great, excellent. And just as a very quick overview, when talking about things that we can do with genomic tools, and this goes way beyond something like eDNA. I'm talking about really looking at genetic variation within a species and what that can tell us about the recent history of individuals and populations. So that includes things, I'm going to talk a lot today about the sources of new populations, where things coming from, often at a really fine scale. How much dispersal is there among regions? For marine species, this is often a big question, including for management. You know, are you getting most of your new green crabs, for example, locally, or are they coming from up and down the coast? I can tell you about genetic diversity, which can potentially tell you about the future potential, adaptive potential of a population. And it can tell you directly about adaptation. This is actually a big part of my research. And I can tell you that certainly green crabs are adapted to temperature here on the West Coast. I'm not planning to talk about that in this talk, but if you're interested, come and find me. I would love to talk to you all about chromosomal architecture at another time. So just a really brief history of methods for population genetics. Basically, we started small, just looking at one piece of DNA, one sequence, you know, maybe a couple hundred base pairs. And a lot of you may be familiar with kind of the CO1 or 16S. They're often used as barcoding genes for species, but a lot of early population genetic tools use these too. We kind of passed through, you know, a couple of different eras of being able to look across more and more of the genome until now in some species, in some systems, we can actually look at the variation across the entire genome. You can kind of think of this progression of tools as being a lot like the progression of kind of video game graphics, right? You know, the tools that just look at one little piece of the genome, they give you some idea of what's going on. We've got our little 1981 Donkey Kong Mario over there. But the more and more of the genome you look at, the more and more you can see. And I would argue we're kind of getting to this point where we're actually kind of getting the X-ray view of what's going on. And just very briefly, all the data that I'm going to show you today is based on looking at single nucleotide polymorphisms, or SNPs. And so essentially, this is 3 different individuals, just looking for places where they vary by a single A, T, C, or G, one base pair. So it's kind of the smallest unit of genetic difference. And individually, there may not be that much information in one of these, but if you look across hundreds and thousands and even millions of them, they can tell you a huge amount about how animals are related to each other and kind of population structure and other things we're interested in. I'm going to tell you 3 West Coast mostly vignettes of work my lab's been doing, looking at invasive sources and ongoing dispersal with these tools. I'm going to talk a little about white-fingered mud crabs. If there's anyone here who's more estuarine than fully marine, this one is for you. And then the Trilla schlosseri, golden star tunicate, and finally the green crab, which you've had a lot of introduction to and will continue to in this meeting. So first, I wanted to mention talk a little bit about this white-fingered mud crab, or Erythroponobius russii. And this is an estuarine species. It's usually find it between about 3 and maybe 18, 20 parts per thousand. And it has a, crab larva. Its larval duration is 2 to 4 weeks, but it has a really interesting behavior with the larvae. It's very estuarine. It wants to stay more in the brackish water, so we've evolved these mechanisms to keep from getting swept out of estuaries.
It's native to the east coast of North America. It's introduced a lot of different places, including the West Coast, California, and spread up to Oregon. And this is work that an undergraduate, now grad student at Hui Kilabakri has done a bunch of the analysis for the invasive work. So just to give you a quick kind of introduction, what does this guy look like at home? These are all the sites that we've sampled. This is all the native range. And then this is a principal components analysis. It's one of the ways we look at kinetic data. It's one of my favorite ways because I think it's fairly intuitive. This is just another way of taking this intense multidimensional data. In this case, we're looking at almost 30,000 different SNPs or places across the genome and kind of condensing it down to 2 dimensions that tell you something about how individuals are related to each other. So each dot is an individual color-coded by where they came from, and the closer they are in space, the more closely related they are. And you can see that there's a really nice crystal structure. All of these crabs pretty much fall in a tiny little cluster of their own estuary. And just we can tour that very quickly. We see Louisiana and Texas, Apalachicola. This is south of Cape Canaveral on the east coast, north of Cape Canaveral on the east coast. And these all really mimic some of these larger biogeographic traits because often transitions in species assemblies as well as genetics. We get South Carolina, and then the Northeast is kind of in a mass on this, but that's really just because we're looking at the biggest population structure. If we do this analysis again, just in that area, you can see that even up here, every estuary has its own distinct genetic signature. That's unusual when you're looking at marine stuff, as you'll see later. And it's likely facilitated by that behavior. The larvae really stayed put in the estuaries where they were born. But we can take advantage of this really strong genetic structure in the native range to ask some questions about where these crabs are coming from and potentially tracing them back to their sources with a lot of precision. So where are invasive populations coming from? I'm just going to show you data from 3 populations we've looked at so far. Oregon, where they were first found in 1950, Finland, 2009, and Japan, 2005. And you may not be able to tell, but those little X's are all in that northeastern cluster. So all of those populations originally came from somewhere in the northeast. We can look a little bit closer and get a little better idea of what's going on. So first, those Finland crabs appear to have come from the Chesapeake Bay, somewhere very close to there. You can see how closely they cluster with that source. There's other analyses I've done as well, but like I said, I think this is the easiest way to kind of look at these data. And really interestingly, we have what looks like a secondary introduction. So those Japanese crabs almost certainly came from that West Coast population. You can see how closely they clustered with each other, much more closely than with any other site. So I'm still in the process of doing some more analysis, trying to figure out kind of exactly where they may have come from. Our best guess is that they may actually have originated also from Maryland. They just had a longer time to diverge, and so the genetics aren't quite similar. But that was a bit of a surprise for us to find that secondary introduction in the data. So just as a, like I said, a quick introduction to the source tracing. In this case, we can trace those introductions, possibly in some cases to the level of a single individual estuary, facilitated by this high throughput genomics and also the life history of the crab. And so this kind of thing can help illuminate complex introduction networks, things like secondary introductions that otherwise we may never know happened, and help identify likely vectors. In this case, it's not likely ballast water. These guys love to hide in oysters, and so moving oysters around tends to move these crabs as well. Another kind of vignette is the gold star tunicate. This is all work that my student Zach Tobias has been doing. So he gave me these slides, and if you have very sophisticated questions, I'll probably have to refer back to Zach. Probably a lot of you are familiar with this. It's a colonial tunicate. I think it's probably the prettiest colonial tunicate, with its little star-shaped zooids. It has these cute little tadpole larvae, and they really don't go very far at all in contrast to a lot of the crabs. They settle out in an order of hours. So these guys disperse broadly on hulls and other fouling vectors, but the larvae don't go very far once they've gotten into a new area. And they have a long history of introduction spread, right? As long as we've been moving ships and things around the oceans, we've probably been moving Petrolis and a lot of these other fowling species. And in fact, they've been moved around so long that they're considered cryptogenic. We're not really sure where they're native because by the time we thought to care about what was on the bottoms of boats, they were already in a lot of different places. The thought is maybe there's a clade in the Mediterranean and a clade on the East Coast, but I think that the research is still trying to tell us what's going on there. They've been successful thoroughly in a ton of other places. And so I'm going to show you some data from work that Zach's done so far. So both on the East and West Coast, he's been able to sequence 4 sites in each. And he's using an approach called low coverage whole genome resequencing. There is a genome available for the species, which opens up a lot of options we don't have with crabs. Crabs have total dumpster fire genomes. I'm happy to talk to folks about that later if they care. But Petrolis is a little better behaved. And so he's actually able to look across the entire genome to look for really fine scale differentiation. And so far on the West Coast, he's looked at San Diego, Santa Barbara, and 2 sites in San Francisco Bay. And he's actively, I think he just finished up a trip to Sitka to do some collections because we're really interested in what's going on in Alaska and in further north than Central California. And this is what his results look like. So we have 3 major separations here. We have East Coast kind of on its own, and then 2 really distinct West Coast groups. And that suggests that there's been at least 2 major introductions to California. I say at least 2 because, Zach's doing a lot more sequencing. Petrolis is in a lot more places on the West Coast. So I imagine we'll figure out some more about where they've come from and what they're doing when we get the rest of those data. When you zoom in on both of those, you can see that they're also really highly differentiated here and there. And what is really kind of fascinating about them is that those 2 sites in Central California, that's Richmond and San Francisco, they're 15 kilometers apart, and yet they're really distinct genetic signatures. And so this gives us a lot of optimism that with a lot more sampling and a lot more representation, especially up in some of the big ports in Washington, as well as up the coast in British Columbia and Alaska, we may be able to figure out where some of these new or new-ish introduced populations are coming from with really, really high precision. So essentially, stay tuned. Like I said, Zach just came back from a collecting trip, and I know folks on the West Coast have sent him samples from other areas. So I'm really excited to see what that looks like. But I think that his early data are really promising for being able to resolve this invasion history and contemporary spread, what's happening right now with really high accuracy or high precision. And yeah, stay tuned. Zach is defending next year, so I think this will all be moving pretty quickly. And finally, the notorious EGC, which has already been beautifully introduced. So I can just tell you about its genes. It has a larval duration of 1 to 2 months, and you know, one descent that a lot of its spread on the West Coast once it got here seemed to be current mediated, especially with these warmer years and ENSO events. They tend to really push green crab populations higher and push them up the coast. And green crabs have been on the West Coast have been a real challenge for traditional genetics. So they are themselves a secondary introduction, which we know again through earlier genetic work. And they've passed through 2 big bottlenecks. So genetic diversity is a lot lower on the West Coast than it is in the East Coast, where they came from, and it's a lot lower still than Europe, where they ultimately originated from. And so those traditional genetic tools basically tell us very, very little on the West Coast. And so that's where using these higher throughput or higher resolution tools, I think, are really helpful. So what can genomics tell us about dispersal and differentiation on the West Coast so far? And I'm really going to focus today on the Salish Sea area. I've been doing a lot of work in collaboration with a number of tribal groups, NGOs, Sea Grant, and others down there, which has been really amazing to get to work with such a great group of people. So how much are crabs moving into and out of the Salish Sea and within the Salish Sea? So just to show you some baseline sampling, these are sort of pre-invasion sites, I'd consider them. That triangle up there is Souk Basin. While that is technically in the Salish Sea, it has kind of an unusual introduction history. Green crabs were first found there in 2012, which is over 5 years before they were first found anywhere else in the Salish Sea. And they're believed to be an accidental introduction along with shellfish, so not a natural dispersal event. And in fact, when I started some of this work, it was prompted by working with and talking with managers who are really interested in knowing if green crab introduction to Dungeness Spit, which is basically just south of that triangle in Washington, if those crabs had all come from Sooke. There's a lot of kind of complex transboundary management considerations going on in the area because, of course, green crabs are not very good at respecting state or national jurisdictions. So the population structure at this point looks like this. And essentially, there's no genetic structure along much of the coast. This is from Central California all the way up to Vancouver Island. And that represents, sorry, I thought I had one more slide there. And what that really tells me is that there's a lot of ongoing dispersal. It's not just that crabs are pulsing or staying there, it's that larvae are pretty regularly getting both up and down the coast. And so you have kind of the same, there's a lot of mixing of individuals, and it gives this kind of homogeneous genetic signature. However, Sooke, that kind of weird artificial or human-mediated introduction in southeast Vancouver Island, is really distinct. It has its own genetic signature, and this is because it's lost genetic diversity relative to everything else. So it's gone through another bottleneck. It's not a signature of new genetic diversity coming in from anywhere else or a secondary introduction. It's just lost a lot of diversity just in the couple generations it's been there. That's likely because it's isolated. So crabs are doing really well in Sooke, but they don't appear to be getting any larvae from outside after that initial introduction. And so that actually lets us use Sooke as a tracer. So we can figure out if those crabs are coming out of Sooke, where are they going? And one of the places they're going is down the coast. They're going down the coast to estuaries in Washington, Oregon. As far as 400 kilometers down the coast, we found larvae that originated from Sooke Basin that have that signature. And that's been going on for a while. So this middle is sort of a hybrid signature. That's if you have an outer parent in that kind of outer coast genetic group and a parent from Sooke that must come down to that estuary in a prior generation. So what about the Salish Sea? I'm going to kind of cartoon this out because once you start adding too much to a PCA, it's impossible to make anything of. And just kind of bin crabs into three groups. That outer coast group that'll be shown in yellow in some pie charts coming up. That Sooke group in blue and that flavor group in green. So Salish Sea sampling, I've been again really lucky to work with a huge network of managers, monitors, and researchers along the West Coast and in the Salish Sea. We've been doing a huge amount of monitoring and have been great about sending crabs to me so that we can take a look at what's happening. So 2017, this was the first question. Like I said, this was prompted by a management question on where are Dungeness Spit crabs coming from? Is it Sooke Basin? And the answer was no, which was a little bit of a surprise. None of those original crabs introduced to Dungeness Spit, of the 12 that I looked at, appeared to have come from Sooke. And we've been working with some physical oceanographers and modelers to get a better idea of the conditions under which larvae are coming in. In 2018, we found some isolated crabs, or by we, I mean all of my collaborators on this. In 1s and 2s and 3s, they mostly came from the outer coast. One came from Sooke, so we do have that avenue as well now. And then in 2019 and 2020, if anyone's familiar with what's going on in the Salish Sea, just tons of crabs are found in some of these eastern bays. They have both genetic signatures and they seem to be mixing. So the picture is getting a lot more complex in terms of what's happening out there. And that mixing is just kind of continuing as we look into 2020. I'm doing the analysis now to look at more 2021 samples and see what's happening. So kind of what we're pulling out of this so far is that green crabs are really, this is evidence they're really traveling extensively, both up and down the coast and into and out of the Salish Sea. And that definitely for a lot of these outer coast invadants, poses some challenges for management where if you would want to manage it in estuary scale, that may be somewhat helpful, but most of your larvae are coming in from, or many of your larvae are coming in from outside sources that you may have no control over. And, unfortunately beyond, right? So of course we know that king crabs just made it up to Alaska. In 2020, they were first found in Haida Gwaii. In 2021, a number of sites in the Strait of Georgia, in Metlakatla, as Linda just told us recently. And I just want to show you, I have updated, you can see the little red X, the slide that I put in a presentation that I gave just earlier this year, unfortunately. And yeah, the predictions are that green crabs are probably physiologically able to handle some of the colder temperatures and potentially spread north and persist if they can get there. And thermal biology in green crabs is another major research interest of mine, so that's something I'm quite interested in as well. So with EGC, genomics help to illuminate dispersal and dynamics and hopefully help inform management priorities and scales of management. And oceanography is really key with green crabs, and we're working with oceanographers to better understand this. Some of these isolated populations can diverge really fast, and they can be used as tracers to help us ground truth dispersal models and make sure that they're really accurately reflecting what's happening with farming. So as a general wrap up, I think I had said in my abstract, I would give kind of general advice on using these tools, but I think the biggest thing I want to mention is just, I think these genomic data can be really useful, but they're most useful if you use them in a broader context, in the context of all the ecology, the management, physiology, and anything else that's happening. They're really much less useful in isolation. And I'm really interested in how these data can be most useful to management and to managers. So I would love to talk with anybody who has thoughts or interest in that. And just very quickly, finally, PSA, my student Zach, he's sitting on the job market next year. He's really great. He does all kinds of stuff. And with that, thank you so much, everyone, for listening. I'm sorry, I think I ran a bit over.
Time for a question or two, like the next talk. Anybody has any?
Yes. Yeah, I mean, and again, I have pictures, but from my perspective, if you really want to make a dent in a lot of these coastal AGC populations, then doing as much as you can simultaneously is probably really helpful, because all it takes is one more year to bring a decent number of larvae in from other places. The exception are those isolated sites, one in California as well, that I didn't show you, but Souk. That's a site where local management, if you could take the crabs down, might be really effective. They don't seem to be getting into Souk, they're just coming out. With the caveat that I suspect that might change now that there are a lot of crabs being found in the Eastern Salish Sea, because oceanographically, that could potentially be a larval source that could get into Souk.
Is there anything unique about that site in terms of the environment that's really not receiving?
Yeah. I don't think it's that. I think it's just oceanography. It's kind of a long, weird entrance to it, so it's a little hard to get into. But the biggest thing is the prevailing currents in the north of the Strait of Manchukuo are cloudbursts, especially when larvae are in the water. So basically, the currents that would bring them crabs, there haven't been any crabs to bring. That's just changed in the past couple of years. So I'm interested to revisit Souk and see what's going on there. But yeah, oceanography is really important.
So sorry.
Okay, well, thanks again, Carolyn. And our next talk is Julieta Martinelli. She's a postdoc at the University of Washington. She's going to be talking to us today about prevalence, distribution, and control of shell-boring polychaete oyster farms from California to Alaska.
Thank you very much. Okay, can everyone in the back hear me? Yes? Okay, so let's get started. I think I might be the only oyster talk, so I'm very excited to talk about oysters here today. And to get started, I want to okay, so I want to acknowledge, oh, does that work? Yeah. So funding from the Western Regional Agriculture Center, who have been funding this project for 3+ years, and our 35 industry partners up and down the coast from California to Alaska. These are mainly oyster growers who have not only provided me with thousands of oysters to look at, but they've also shared a lot of their expertise and knowledge and have really guided us throughout the project and have been very active also in the development of all of our products. Okay, so most of you here probably know that the West Coast is really famous for beautiful pearly oysters like the one that you see here on the image. And a few years ago, our team actually started noticing that this very clean pearly shells started becoming infested with a parasite that leaves very nasty places. So these are burrows that you can see on the margins of the shell. And they may look small now, but over time, these burrows actually turn into blisters that are bumps inside the shell that are filled with mud and anoxic. And a couple of years ago, we were able to confirm that the parasite that creates these marks inside oyster shells is a parasite called Polydora webstri. It is a marine worm, and they're pretty cute when you look at them under the microscope. They're tiny, they're pink, they're adorable, but unfortunately, they are really harmful for the aquaculture industry, and they are really notorious invaders that have caused problems throughout the world. So in this map, you can see places in the world where Polydora has caused a lot of problems for aquaculture industries. And after we found it in Washington, we wanted to see if it was also found in other places on the West Coast and what we could do about it. So today I'm going to be sharing with you the progress our team made understanding the distribution of Polydora and other shell-borne polychaetes that we found. Also, I'm going to be talking a little bit about some of the treatments that we've co-created with oyster growers to control this pest. And I'll also share some of our latest findings about the role of the environment, trying to understand this infestation. Okay, so let's get started with the distribution. So in order to map out the distribution of these polychaetes, I worked a lot with oyster growers, and I collected or was sent 25 to 50 oysters from each of these 35 oyster farms over 4 sampling seasons. And I looked at oysters that came either from long lines, split backs, grown on the beach on the bottom. And in addition to looking at the oyster shells, we also used molecular techniques. So we looked at 18S and CO1 as molecular markers to identify the ones that we're finding in the oysters. And very broadly, to give you an idea of the prevalences that we found throughout the West Coast, in this map, you can see the average prevalence over 4 sampling seasons. And you can see that from California to Washington, about 25% of the oysters I looked at were infested with the shell-borne polychaetes. And for Alaska, we found prevalences of a mean prevalence of 40%. So in some areas, a lot more than that. But of course, there is a lot hidden in these averages. So to give you an idea of the variability, I'm going to show you what we found for Washington. which is where we have most of our partners located. So in this map, you can see different farms where I collected oysters. This is only Pacific oysters. So the focus of our project has been Pacific oysters. And the numbers indicate the prevalence bound in each of these different farms. And for example, if we focus on Willapa Bay, we can see that in farms that are very close apart in space, there's a lot of variability between 17 to 78%. So overall, one of the main things that we've been noticing is that there is very high variability across growth methods, across sites, across seasons, across states. And in addition to looking at the prevalence, like I mentioned, we also looked at the worms. So whenever I found an infested shell, I cracked it open, took out the worms with a lot of love and care because they are very, very small. And we use this to extract their DNA and sequence 2 genetic markers. So right now we're close to the end of this whole genetics, the genetic part of the project. And I want to share what we've been finding on a state-by-state basis. And here I want to clarify that in particular for the oyster farmers, it is impossible for them to tell what species a worm is. They are tiny, they have very few diagnostic features, but for us it is very important because we can see which worm is where, we can track the infestation, and we can also understand differences between states, which is pretty important. Okay, so to get started with Washington, this diagram that you see here is a haplotype network, which allows us to visualize the relationships between DNA sequences between different species. So in the case of Washington State, for example, we found that 74% of the worms in our samples belong to a mystery worm. We don't know what it is. It might be a native species that has gone undescribed. We also found Polydora webstri, like I mentioned before, and we have some species of Bocardia, Bocardiella, Dipolidora. If we look at the results for Oregon, in Oregon we have mostly Polydora webstri, and we also found Polydora hoplura, which is another notorious shell-borne polychaete that has caused many problems. And if we go to the map, the haplotype network from California, in California, we also have the same mystery worm that we found in Washington. We have about 50% of our samples that have Polydora hoplura and again, webstri and a different mystery worm. And in Alaska, we only have 3 worm sequence so far. So take this with a grain of salt. But we also have a worm that we don't know what it is. And it's also important here to notice who's missing. We don't have any indication of having webstri or hoplura in Alaska, like we found in the other states. So we are concerned, but also very really thrilled with these results because we're able to see in a lot of detail the genetic diversity that we've been finding in these polychaetes and actually find differences between states, which is really important to track the infestation and understand what's happening. And that brings me to some of the treatments that we've been developing. So in our project, stakeholder engagement is super important. So we have a group of oyster growers that are part of a healthy oyster string committee. And we worked with them, and over many different sessions, we developed treatments that could be applicable in farms. So things that they could actually do and carry out in the farm. And when we started doing these brainstorming sessions, we came up with some features or characteristics we want our treatments to have. And this is, we wanted the treatments to be applicable in most farms, regardless of the size. We work with very small family-owned businesses to multi-state companies. So we wanted hopefully to come up with solutions that could work for most of them. We also wanted to have techniques that were accessible, so nothing too expensive. We also didn't want to disrupt harvesting or any other important farm processes. And lastly, we also wanted to use clean techniques, so nothing that involved chemicals or potential regulations or approvals from FDA, etc. And after a few rounds of pilot tests, we came up with 3 treatments that were successful. And these treatments are putting oysters in a fridge for 3 days. So this is a cold brine treatment. We also had a combination freshwater dip for 1 hour, followed by 2 days of drying. And our last treatment was simply putting the oysters out to dry in grow-out bags, like you see in the photo. And of course, we had a control that were oysters that were kept in the tank, not treated in any way. And this was done over 2 seasons, in the spring and in the fall, to avoid the extreme temperatures of winter and summer. So let me show you what we found. In this graph, you can see the number of live worms found per oyster in each of the different control and treatment groups. And for the control, you can see that we found live worms between 2 and 8, which makes sense because these oysters were not treated. And then for the dry treatment, that was our most effective treatment. We found 0 live worms per oyster, and the other 2 treatments were also pretty effective. At most, we found 0.16 of a live worm per oyster. So they were very effective in general, and this was consistent for both seasons. Something that is important to mention is that we did find 4% oyster mortality in the spring treatment, in the spring season only for the dry treatments, but no mortality in any of the other cases. And I forgot to add the citation, but this work was accepted last month for publication in Aquaculture. So you can go check that out or let me know if you have any questions. And we also developed an outreach video with Jackson Rose, their project monitor. And you can find that video with us actually in the shellfish farm explaining these different treatments. And that's on the YouTube channel called This is Aquaculture. So all of that is explained there, basically how you would carry out these treatments in an oyster farm. Okay, and that brings me to the last part of the talk, which is understanding a little bit more in depth the role of the environment. So at the start of my talk, I mentioned how we had been noticing that there was a lot of variability in the results that we're finding in terms of prevalence across season sites and states. So having the massive data set that we got over 3 years, we started trying to look for general patterns to see if there was anything that would be consistent between states. And the main thing that we found was that infestation was increased with shell heights, and it was also significantly higher in winter months. So in this graph, you can see the predicted infestation for a given oyster on the y-axis and the shell height on the x-axis. And we found that in general, winter season had significantly higher infestation rates, and larger oysters also had more chances of being infested than smaller oysters. But of course, we did find some variabilities between states. So the higher prevalence in winter that I was talking about was valid for all states, with the exception of Oregon, where we found no difference in the likelihood of an oyster being infested in summer or winter. The other interesting differences that we found, particularly in Oregon, was that in terms of the growth method, in general, we found no difference between oysters that were grown on and off bottom, but for Oregon, the oysters that were grown on the bottom, so on the beach, had more infestation than the ones that were grown off the bottom. And the last thing that we've been working on is understanding a bit more in depth environmental variables. So to do this, I put together massive data set, collating all of our information with oyster metrics, with 19 buoys and monitoring stations in the 4 different states that we've been working on. And you can see in this map, a lot of the yellow dots are the farms where we collected oysters, and some of the green ones are the buoys or monitoring stations where we got the environmental data from. And initially I was looking at 1 to 5 different variables per buoy. And to make this story short, the data is very messy. The quality of the information between states is very different. So we decided to focus on Washington State, which is where we have the most information from. And I'm going to give you a quick overview of the only results that was significant for Washington, and that is pH. So of all the different variables that we looked at that included salinity, sea surface temperature, turbidity, we found that for Washington oysters, the predicted infestation increased in more alkaline and saline areas. And we think that this is actually more related to the environmental tolerance of the worm, and not necessarily with the fact that oysters might be easier to burrow into, or let's say are more dissolvable at lower pH. So this was something that we were clearly not expecting to find, but it was a very interesting result, and it might reflect the fact that the larvae of these worms are not super tolerant to acidic conditions. So potentially could be good news heading into the future for some of these areas that have a lot of acidification happening lately. Okay, so at the start of my talk, I mentioned how we all value the beautiful pearly oysters from the West Coast. And today, hopefully I convinced you that our team has been doing a lot of work to try and understand this problem and to come up with solutions that hopefully can get them back in shape so we can keep them clean and shiny for many more generations. Thank you very much.
We do have time for a question, if anybody has a few. Yeah, Lisa.
Over there.
On the worm life cycle for helping some of the management of future introductions or invasions.
That's a really good question. So we know in terms of our results that we found that the infestation was higher in the winter. We know that these worms spawn in the summer when the temperature is higher. So that's why we think that the small larvae make their way into the shell in the warmer months, and in the fall, that's why we see higher prevalence in the winter. So that's one of the main things that we've been finding. However, in places where it's warm year-round, like Hawaii, our industry partners there that were not part of the study, but we've been talking to them outside, they have really high infestation year-round. So the life cycle probably varies in different places depending on the water. I don't know if that answers the question. Yeah. Over there in the back. Yep. Yeah.
Yeah, good question. Yeah, Gordon King, Taylor Shellfish. 2 questions. Was it randomized sampling to determine the frequency? And the second question was, do you ever see it in other species such as Crassostrea sycamore or Streptococcus?
Yes. So for the first question, the frequency of flights.
So you're listing frequency of infestation. And so I'm wondering how randomized your sampling was.
So the oysters that I collected in person, I actually went out to the different farms and we tried to collect 5 oysters from different bags, or if there were samples on bottom from different areas in the same beach. And in terms of the ones that were sent to me by the farmers, we also asked them to do the same. Ideally, if they were sending 25, we asked them to get 5 from 5 different bags.
This was in general respected, but of course there was a lot of variability. And in terms of the other species, yes, we have found them in Virginicas in Washington. We've also seen them in Kumamotos and unfortunately also as well in Olis. And I actually have a side project that we can talk about later if you want, but we've seen them in Olympia oysters out in Willapa Bay in Bay Center that are about 100,000 years old. So it's very likely that there's a native species. Yeah.
Gotta go to out.
Thank you. Back to green crab, Washington Department of Fish and Wildlife, AAS unit lead and incident commander. Right. Just the arrow.
All right, thank you. So, the deal here is how to cooperatively manage the functional eradication out of European green crab. So it's not really about how to do it because I'm still learning and we're all learning how to do this, but that's really the method and the madness that we're trying to follow in Washington State. So in Washington State, our European green crab is classified as a prohibited level 1 species, which makes it the most concern in our state and mandates our department to do something about it. Zebra quagga mussels are another one on that list. So if we have a detection, we would immediately work on it. And that's what's going on with European green crab. And so within our state, we also have tribal jurisdictions and we have federal jurisdictions. So this is a big issue across the range. Back earlier this, in 2021, our department, in coordination with our tribal co-managers and other partners, found a significant increase in the European green crabs populations. And we were started raising an alarm on these. And then we feel like we're still at the front end of the invasion curve, more so in the Salish Sea than we are on the outer coast. But it's still early in the invasion, and they're definitely a threat to the environment, the economy, and human well-being of the state of Washington. So with all that, on January 19th of this year, our Governor Inslee issued Proclamation 2202, which basically ordered our department to begin implementation of emergency measures as necessary to effect eradication or to prevent the permanent establishment and expansion of European green crab. So this is I'm missing a map on here. I'm sorry, let me see. No, that's odd. Well, I'm just going to keep going here. So anyways, in 1998, imagine you have the coast of Washington on the right side there, and you go back to Carolyn Tipholt's map, and you saw that little triangle. Well, the triangle is back for Sook Basin, and that's up at the south end of the Vancouver Island. And to the right of that is the Salish Sea, and then out of that is the coast. So 1998 was our first detection of green crab, and that was in Willapa Bay and Grays Harbor. On the outer coast, that was that El Nino year, and there was a large progression up the coast all the way into the west coast of Vancouver Island. In 2012, as Carolyn mentioned, that's when they first discovered the green crab in Sook Basin, which is in the Salish Sea. And then in 2015, we started working with our colleagues in Washington Sea Grant and to help them initiate an early detection monitoring with citizen scientists, which led to our first detection in the proper part of Salish Sea in the Washington waters in 2016 in the San Juan Islands. 2017 is when the Macaw tribe found crab out in Macaw Bay, and that's when U.S. Fish and Wildlife Service found crabs in Dungeness Bay.
And Dungeness Spit is in the Strait of Juan de Fuca. And again, I think if you remember with Carolyn's, that was just right below the Sook Basin. And we were very concerned that that Sook Basin was feeding the larvae into that Dungeness Spit area. And then 2019 was our Lummi Sea Pond detections. That's the Lummi Nation. They have a 750-acre aquaculture facility there. It's a intertidal area with tide gates that aren't functioning at this point. And basically, it's a very good incubator for green crab. So that's just telling you where those are. So on the right-hand side, when we talk about the invasion cycle and we talk about how many crabs did we actually find throughout the years, back in '98 when that initial infestation happened, the total number of crabs we caught was 364. The next year was 507, and then it started tapering down again. So back, when you get into 2003, 2004, we were finding very few crabs out there. So basically, they weren't reproducing, and they were living out their life cycle, which is about 6 years, and then they were gone. And then between then and 2016, there was ups and downs, little pulses, El Nino events, bringing in new crabs into the West Coast, but they never persisted. Then in 2017, we started seeing an uptick, and it started progressing pretty rapidly. Again, that's both the coast and the Salish Sea. So, 165, then almost 1,200, then almost 2,000. And 2020, that's over 5,000. And then between 2020 and 2021, it jumped up to 103. Most of those, 86,000 of those were in the Lummi Sea Pond. So that was just, incredibly, that's what really drove the emergency measures. So 2018, again, keep seeing those increasing populations. In 2020, the legislature approved over $780,000 proviso, and half of that was a pass-through funding to the Lummi Nation and to the Makah Tribe and Washington Sea Grant to really help them cooperatively manage this situation. 2021, we got another 2.3 million ongoing funding. That's specifically, these are numbers specifically for green crab. And 1.2 million of that was passed through again to the Lummi Nation, Makah Tribe, Washington Sea Grant, as well as the Northwest Straits Commission. In 2022, we have every year the legislature meets in our state. Every 2 years, it's the biennial funding, and then we have a supplemental funding. And so the supplemental funding was 2022, and that's after the governor issued the proclamation, and the legislature gave us another $8.6 million ongoing funding, of which 3.2 million was passed through, and another 1.5 million is now available in grants. So, oops. So as of September 4th, just in 2022, we've caught over 175,000 green crab, coast and Salish Sea. Cooperative management, hey, we got a map. And so we have multiple jurisdictions within Washington State, multiple management priorities, management types, and operational complexities, resource capacities, sensitivity habitats and species protection, aquaculture operations. How are you going to manage all that statewide? Well, part of it is magically appears a budget strategy. And this is the breakdown of the funding that we've received in the last 2 years from when it came. So part of that, the upper two rows there are for our department. There's a coastal grant program that's about $500,000 a year, but this was over a couple-year period. So we got over 800,000 for that. And down below, there's another grant program, 1.4. These grant programs are really important because you just don't know when you go to the legislature and you say, I need money for this, there's a lot of gaps. And so we tried to fill those gaps with these grant programs. And that's been really successful, and we're doing that, getting the money out. So so that supports our statewide lead, pass-through funding to key tribal and co-managers and partners, and grant funding for emergencies and gap management. So that's the budget strategy that we're looking for. So the other, how to actually pull everything together, how to cooperatively manage this, we felt the best way to do that was an incident command system, because it respects all jurisdictions. It's an excellent communication and coordination tool. There's a common language in this, and that's really key when you're talking about trying to make everything work together. And it's effective for multiple jurisdictions across those large geographic areas, and ensures critical needs and issues are effectively addressed, and it provides management transparency for those jurisdictions, impacted entities, and the public. These are all really key because you can't do this in isolation. It has to be open and transparent. So this is your spaghetti map here of what a emergency measures incident command system looks like. And basically the center part here is the traditional incident command. On your left-hand side, there's a dashed line to the multi-agency coordination group. And that's a policy group that I was actually meeting with Teresa just before this. And that's why I had to switch my presentation timeline. But that's a policy group within the state that helps guide us in these decision-making pathways. On the far left are the federal agencies, and they don't have to work with the states, but in this case, we are working with the states. But the dashed lines just make it clear that there are other options here. There's different ways that management can happen. Similar thing on the right-hand side, we have numerous tribes. We have over 20 individual tribes within that area that have management concerns, and they're sovereign nations. So how do you work with them to respect their sovereignty and make sure that they work within these groups? So there's ways they can work independently, and there's ways that they can work within the MAC group. We have 2 tribes that have seats at the Salish, at the MAC group, which is the multi-agency coordination group. If I didn't quite get the acronym there, but they only represent their tribe. They don't represent all tribes. So we get a tribal perspective in that, but we also do a lot of outreach to the tribes individually in this situation. And below, we have liaisons that connect those, and then there's the incident command, which is myself. I'm the incident commander for this situation. I was delegated by our director to be such. And then underneath, these are not necessarily people, but they're activities that have to happen. Planning has to happen, logistics have to happen, finance and public information and outreach, safety. Safety is number one. So how do you make sure safety is done on a statewide basis in this situation? And then you have operations, the actual operations, and then within operations, how do you divide and conquer down there? And in this situation, we have different branches, and I'll get some more detail with that. So again, upper part, this is basically the policy aspect of what we're dealing with. And then again, dealing with those entities, the federal and tribal entities, because they're sovereign and they don't have to listen to the state, but we all want to work together. And then dividing it up into our specific branches. So as I talked about the multi-agency coordination group, these are the state agencies, the tribes and federal agencies, the NGOs and private entities that are part of this the MAC group is short. So their tasks are review and recommend proposals for green crab funding. We just reviewed a proposal today to support the U.S. Fish and Wildlife Service on Dungeness Spit. They have they've been working out there for a long time, but they needed some critical funding to make sure that their citizen science group could keep functioning over the next few years. And that's an important piece. It was a gap that was missing. We're also developing and implementing a fiscal year 23 strategic action plan, and then working towards developing that for fiscal year 24. Again, we're on an emergency measures basis here, and we want to try to transition it out. So that's the next part is going to be then working on that collaborative management plan for long term. And then determine when does this emergency end? Because it's got to be an ending. So when is that going to end? So the high-level actions that we're working under, obviously facilitating implementation of the proclamation, health and safety of all participants. That's always a critical part of any incident command. You don't want, no crab is worth any human injury or life. and reduce or contain green crab populations below levels that result in economic, environmental, and cultural harm. And collaborative and transparent and post-emergency transition to long-term green crab management. They're going to be there. There's no way to eradicate them. We could eradicate them temporarily, but as Carolyn said, these things are active. They're moving up and down the coast. Larvae are going to get in there, and we need to deal with it. It's like a wildfire. You get sparks coming in, you get a little flare up, you jump on it, and you knock it out. That's the key to effective management if you're doing it, ahead of the curve in early, in these situations. Alaska is in a really good position right now. They have this detection. You're at the early part of the invasion curve. This is the time that people need to act. So we have two branches. Okay, so I'm trying to look at these things. So we've divided the area into two branches. I'm sorry these maps are not working out very well on here, but basically this area on the right, Strait of Juan de Fuca, on the right is all Salish Sea. Everything on the left is coastal. We've divided those branches into management areas. And again, this is just ways that we can take this information and parse it out so it can be manageable. Some of these areas like the South Coast may not have much green crab, and so we don't do much there, but we want to make sure that we capture is anything happening there or not. So we have 13 of these management areas, and within each of the management areas, we have coordination areas, and that's all how we're trying to just, pull the data together. So data management is another aspect. So this is some of the stuff that we would send out to all our partners. We have multiple people, to tribal, shellfish growers, lots of people out there collecting data for us. Well, not collecting data, they're actually killing crab and pulling crab in, and we want to know how many they're doing and how many traps. So this is just some of the data information that we're asking them to do, both on an operational period, which is common within an incident commands where you have a 2-week operational period, what happens within those 2 weeks periods. And then we also want to know, what are you planning for the next operational period? So we can project and guide resources for that. Communications is another part. Situation reports are an important part of incident command. So every 2 weeks, I put together the situation reports on the left here, and they provide a lot of detail information about that. So for example, here's more detail on a line by line. Here's on the far left is the management area. The next column is the coordination area. And then you have the what type of action is happening there. Are you doing prospecting? Are you doing control? Are you doing some other action? And then how many green crab were collected prior to that, how many in that operational period, and how many total for the year. And now we're adding how many trap days for that operational period to give you a rough estimate of activity and effort in those situations. On the right is a more public facing. We don't want to be disseminating that level of information out to the public because there's sensitivities with each of our partners. So we produce a public facing outreach update, and that's on the right. Other resources that we have stickers. The crab team is just an amazing entity. They do a lot of work with the citizen scientists, hundreds of citizen scientists. The example on the right is some of the signage that we put out there, and to help people understand what green crabs are. Unfortunately, we might think, oh, green crab, they're easy to identify. Well, it depends. If there are a lot of them around, they're easy to identify. If they're not a lot around, we're finding like a 99% misidentification rate. And most people are like, oh, I'm glad. I was just about ready to kill it and, smash it. It's like, well, that was a native crab. You have to be really careful about what you can do or not do. Is this probably on a timer? Anyways, what is functional eradication? So I'm running out of time here. That's another part. When do we know we've hit functional eradication? When do we know that we've hit that threshold where we don't have to keep trapping anymore? Yeah, there's crab out there, but they're not in a point where they can reproduce effectively and create a sustainable population. That's really what we're looking at here. And it's a question we need to answer. over time. And this again just puts some identification of where we're at between 2021 and 2022. The upper left is Lummi Sea Pond, 86,000 last year, only 73,000, no young of the year this year. Like, wow, that's great. So we got a lift from Mother Nature here, maybe a really cold spring. But we're looking at these numbers and trying to figure it out. So anyways, next steps, continue working on all the different activities and such. And we're going to be continuing, winter trapping this year. We haven't done much winter trapping before, but it's an important piece to keep going. So I have that. So anybody see what's in the crab? All right. That's it.
One question?
One really good question. It only has to be really, really good.
I look forward to talking to you a little bit more about this, but my question to you is, maybe I'm putting you on the spot here a little bit, but what's happening north of the 49th parallel? I know what's happening in terms of tribes and what they're catching, but there's not a lot of talk about our government action on it. So I'm just wondering if you're working across border at all on efforts with this.
Great, thank you very much. Yes, in 2019, Department of Fisheries and Oceans Canada signed a action plan with our state to be transboundary management of European green crab. Since then, DFO has hired a management person, Rennie Talbot, and they're also working with First Nations in the Salish Sea, and now the Coastal Restoration Society has been doing what they're calling industrial trapping, starting to do more industrial trapping in Sook Basin and Clayoquot Sound. So there's a lot of work going on with our colleagues in Canada, where we feel like we're doing really well together. And this is something we want to export more, how better to improve communications and coordination across our boundaries between states and between us and Canada.
Okay, thank you, Alan.
I would encourage everybody to speak out, all the speakers from this morning. Can we thank all of our speakers from this morning again for applause? I want to acknowledge the virtual participants that are out there in the room. So thank you for joining us for the discussions this morning. We know you're out there, and so thank you for participating. I wanted to make a couple of quick announcements before we break for lunch, which, remarkably, we're still kind of in good shape here. We got plenty of time to go eat. So, and our lunch is being sponsored by iAstonish, and it will be across the hallway in the Katmai King Salmon rooms over there. So we'll go over there shortly. But then after lunch, we're going to have 2 workshops that hopefully many of you have signed up for. If you haven't, that's totally fine. You can still join a group, but we have 2 of them. And in this room here, we're going to have the HACCP planning. What is it and how to use it? So, and if you're not familiar with HACCP, so that's hazard analysis, critical control point. And that's looking at any kind of activity in a natural resource setting and trying to examine those places where you could be inadvertently spreading invasive species. So it's going to be a nice overview. It's not the full multi-day course. It's a nice prep for you guys to understand the concept. So Parag Shamai and his dynamic team are going to be hosting that one for you guys, and that'll be in this room here. And then across the hallway in the Dillingham room is our second workshop. So it's the Words Have Power, More Effective AIS Common Name. So again, this is going to be an examination of really how we as professionals have been kind of traditionally using certain words to describe our work or to describe species, and really kind of taking a different lens on that. So we have a really good powerhouse team that are going to be sharing some nice tools with you. So that's led by Sam Chan with Oregon Sea Grant, but a lot of really great people are coming to the table to help us with that one as well. So once those workshops are done, you guys are kind of free to go for the day. And then we'll come back here and start again at 8:30 in the morning. So with that, I think that's all I wanted to say. So thank you. So, oh wait, Dee has something she wants to say. I mean, I certainly cannot glue people to seats, but I think out of respect for everybody that, you know, kind of maybe stick with something and, you know, if you can do that, that would be great. But there's nothing stopping you from moving. So my answer didn't say answer that. So technically speaking, you could. All right, so thank you, everybody. And again, lunch, oh, I did want to say one more thing. So lunch is a plated thing. It's not a buffet. So if you didn't pre-register for this event, you don't have a name tag that's typed out nice and pretty that I did for you, then so if you have one of those nice name tags, that means that you have a plate of food over there. If you did a handwritten one when you walked in the door, I'm sorry, but hopefully I think you have plenty of time to go find a sandwich and rejoin us for workshops. So thank you, everybody.
Real quick, I want to take a panoramic picture of everybody, so wave and say hi. Keep it up. All right, thanks everybody.
Okay, awesome. Thank you.